All right, so for this problem, you notice it's very similar to the things that we've done before. We're finding the antiderivative, which we're going to call capital F here, of lowercase f. So we're finding the antiderivative of this function, just we're satisfying a specific condition this time. Our process, though, starts the exact same way, which is find the antiderivative of our function. So we're going to start there. So I'm going to have capital F of x equals, then we start going through doing the antiderivative. So x to the 6th becomes x to the 7th, and then because that's going to have a derivative of just plain old x to the 6th, not 7x to the 6th, I want to multiply that by 1/7. Basically, I'm multiplying by the reciprocal of my new exponent there. All right, and we keep doing that through. So then it's going to be plus, my x to the 4th is going to become an x to the 5th. So I have to multiply the 3 that I want by 1/5, gives me 3/5. Plus, now we do the same thing here. X squared becomes x cubed, then I multiply 2/3. And then the most general antiderivative is plus c. Well, the difference between this problem and the previous problems we've done is that because we know that f of 0 should equal 4, we're actually going to be able to solve for c and figure out exactly what number that should equal. That's the only new layer to this particular problem. So then I'm going to go ahead and actually plug in 0 for x so that I can see what that gives me. And my goal here is to get it to equal 4. So we're going to go 4 equals 1/7 times 0 to the 7th plus 3/5 times 0 to the 5th plus 2/3 0 cubed plus c. And I'm just going to solve for c. Now in this case, you probably are already noticing c is going to be pretty easy to find, right? They won't always be, but this gives us a nice way to start. The reason why this one does end up being so easy is because all of these zeros along there create a bunch of zeros, and by the time I simplify that out, I just find that c equals 4. And so then I can now write my final answer, my final antiderivative that meets that condition is f of x equals the same equation I had before, just by plugging in the number for c. Step 1 is to find the most general antiderivative. Thankfully, this one works out a lot more nicely with all those fractions and stuff not really popping into it. This is what you should be looking at. Then you need to go and figure out what c is. And so to solve for c, we're plugging the -1 in for x, and then I'm going to solve that out for c. And so when we solve this out, we end up finding that c ends up equaling 6. Therefore, our final equation, instead of having that plus c on the end, I know my final equation then is going to be plus 6. All right, and so we're going to tackle this problem next. And notice that we're looking to figure out what f is if we're given f double prime. That means we need to find the second antiderivative. Yeah, it might end up being a little bit ugly, it might have a bunch of fractions in it, but that's okay, we can still do it just using all the methods we have before. Start by going ahead and just finding out what the first derivative, the first antiderivative rather, would give us, because it actually gives us the first derivative. And so when we find that first antiderivative, this is what we should be looking at. And again, it's the most general, so we have the plus c hanging on the end there because we don't know exactly what c should equal at this point. Now, having done that, having done the first antiderivative, that got me up to what f prime would equal. But again, we're looking to figure out what f would have equaled. So that means I need to do the antiderivative now of this in order to actually get what f of x would be. So go through and do the antiderivative of this function. And to make sure you got the right start, your first term should give you 1/56 times x to the 8th. For the next term, we'd get 2/15 x to the 6th. Notice it's 2/15 because it starts off as 4/30, and then I'm just reducing it. And then this is the point where things start getting a little bit interesting on the second derivative. So I found the second derivative of all the stuff like I normally would, but then I have the plus c hanging on the end. Well, the antiderivative of c would be cx. And so it's going to actually be, come on, this thing's not wanting to write. All of a sudden, there we go, cx. And then if that's going to be cx then, I still need to make it the antiderivative of that, the most general antiderivative of that. So then it's plus, well, I can't use c again because I already have c. It doesn't have to be the same number. So I'm going to do plus d. And if you had to keep going, you go to e and f and all that kind of stuff. Well, maybe not f, since we're using f already. So you find your first derivative. This is what you should be looking at. And so then when we do the antiderivative of our first antiderivative, this is what we end up with as our final answer. And again, notice we don't have any particular condition we're trying to meet here, so we actually don't know what c or d is, so we just leave them as c and d.